Hello, and welcome to The Sleepy Evolutionist, where deep time meets cozy contemplation and evolution becomes a gentle lullaby for curious minds. Tonight, we're quietly drifting into one of the most profound stories ever told, one that spans 3.5 billion years and touches the very essence of what it means to be alive. It's a contemplative journey through time that will help you understand why your mortality, far from being a flaw, is actually the greatest gift evolution ever gave you. Before we begin this vast expedition through deep time, I'd love to know where in the world you're listening from and what time it is for you right now. Perhaps you're nestled in bed somewhere in Tokyo as dawn approaches, or maybe you're settling into an evening routine in Sao Paulo, or finding a quiet moment in London as midnight draws near. Wherever you are, we're all connected by this ancient story, all of us temporary passengers on the same cosmic journey, all carrying the same precious inheritance of mortality that took eons to perfect. If you find this gentle exploration through the epics both fascinating and soothing, I'd be ever so grateful if you gave this video a like and maybe even subscribed. It really helps this quiet corner of deep time contemplation grow, creating a peaceful space where others can discover the profound beauty hidden in our evolutionary heritage. Now, I do hope this isn't so fascinating that it keeps you awake, though I suspect the rhythmic nature of deep time itself will help guide you toward rest. But if it does keep you wonderfully alert, well, at least you'll have learned something beautiful about the elegant wisdom of life and death along the way. This video is for educational and relaxation purposes only and is not intended as medical advice. So settle in, let your breathing slow to match the patient rhythm of evolutionary time, and allow yourself to become a quiet observer of the most extraordinary story ever unfolded. Let's begin our gentle journey into deep time, where we'll discover how life itself learned to die and why that learning changed everything forever. Let's drift back, far back, to a time when death simply didn't exist. Picture, if you will, the early Earth 3.5 billion years ago, a world where the very concept of mortality was yet to be invented. In these primordial waters, your most ancient ancestors were swimming in a kind of eternal present, tiny prokaryotic cells that divided endlessly, copying themselves with the mechanical precision of cosmic clockwork. These earliest cells were, in a very real sense, immortal. Think of them like a library that never closed, where the books simply multiplied forever. Each bacterium would grow, absorb nutrients, and when it reached a certain size, it would split perfectly in two, creating two identical copies of itself. The original cell didn't die. It simply became two new cells, each carrying exactly the same genetic information. It was like a gentle form of photocopying that could theoretically continue forever, and in many cases, it did. Imagine the profound simplicity of this existence. Your bacterial ancestors lived in a world without aging, without senescence, without the ticking clock of mortality that governs your life today. They were biological perpetual motion machines, tiny engines of replication that knew only growth, division, and more growth. Picture vast mats of these cells covering the ocean floor, forming the first cities of life, sprawling bacterial metropolises where individual identity meant nothing because every cell was potentially eternal. The fascinating truth is that many of these ancient lineages are still with us today. Certain bacteria can still live indefinitely under the right conditions, dividing again and again without ever truly dying of old age. They are living fossils of immortality, quiet reminders of what life was like before death became part of the equation. When you see bacterial growth in a petri dish, you're witnessing a form of existence that predates mortality itself, a biological process that connects directly to your most ancient heritage. But here's where the story becomes beautifully complex. This immortality came with profound limitations. Because these cells never died, they also rarely changed. Evolution requires variation, and variation often comes from the mixing and matching that occurs during reproduction. Without death to clear away the old and make room for the new, Without mortality to create urgency for adaptation, life remained relatively simple for almost 2 billion years. Your ancestors were trapped in a kind of gentle stagnation, eternally dividing but rarely evolving, like a song with infinite verses but no chorus. They had solved the problem of survival so completely that they had inadvertently created a new problem, the problem of perfection. In their immortal simplicity, they had reached a biological plateau where further complexity seemed impossible. Consider the patience required for this vast period of bacterial dominance. For 2 billion years, longer than multicellular life has existed, your ancestors lived this simple immortal existence. 2 billion years of gentle division, of quiet persistence, of life maintaining itself without ever asking the profound question that would eventually change everything. The question of whether living forever was actually the best way to live at all. And here you are, 3.5 billion years later, carrying within every cell of your body the genetic memory of that ancient immortality. Your cells still remember how to divide, how to copy themselves with remarkable fidelity. But they've learned something profound that their immortal ancestors never knew, something that would transform the very meaning of existence itself. They've learned that sometimes, to truly live, one must also learn to die. Think about the bacteria living peacefully in your gut right now, some of them direct descendants of those first immortal cells. They're still dividing, still copying themselves in that ancient way, still practicing a form of existence that predates death itself. You are, in a very real sense, a walking ecosystem that includes both mortal and immortal forms of life, a living bridge between the ancient world where death didn't exist and the modern world where mortality drives everything forward. The profound irony is that without death, there could never have been you. Your complexity, your consciousness, your ability to contemplate your own mortality, all of these emerged only after life learned to embrace endings. Those simple immortal cells, for all their persistence, could never have dreamed you into existence. They were trapped in their own perfection, unable to imagine that limitation might be the key to transcendence. Your ancestors spent 2 billion years in this state of immortal simplicity, and yet every moment of that vast span was necessary preparation for what was to come. Like a river that must flow slowly through countless valleys before it can carve a magnificent canyon, life had to master the art of staying alive before it could begin to explore the profound possibilities that come with learning how to die. There's something deeply moving about imagining those ancient waters, filled with immortal cells living their endless cycles of division and growth, unaware that they were setting the stage for one of the most beautiful transformations in the history of the cosmos. They were writing the first chapters of your story, encoding in their simple DNA the foundational programs that would eventually become your genetic inheritance, your cellular wisdom, your very capacity to exist. As we prepare to explore how death entered this immortal paradise, take a moment to feel grateful for those billions of years of patient persistence. Your bacterial ancestors may have been simple, but they were also remarkably dedicated teachers, spending eons perfecting the basic arts of cellular life, energy production, and genetic replication. Every breath you take, every heartbeat, every thought you think relies on cellular processes they pioneered in those ancient, deathless seas. In the vast tapestry of evolution, those immortal cells were weaving the foundational threads that would eventually support the entire complex pattern of your existence. Soon, we'll discover how life began to experiment with endings, and how that experimentation would open doors to forms of beauty and complexity that immortality alone could never achieve. As millions of years drifted by like gentle tides, life began to encounter the first profound paradox of existence, the unexpected limitations of perfection itself. Your immortal ancestors, despite their remarkable persistence, were slowly discovering that eternal life brought with it a beautiful burden that would eventually require the most elegant solution evolution had ever conceived. Picture those ancient bacterial communities as vast cities that never knew renewal. Imagine a metropolis where no building was ever demolished, where no resident ever moved away, where every street corner remained exactly the same for millions of years. At first, this might seem wonderfully stable, peaceful even. But slowly, quietly, problems would begin to emerge, problems that only the passage of deep time could fully reveal. Your earliest ancestors faced what we might call the immortality trap, a biological catch-22 that highlights the profound wisdom hidden in life's eventual embrace of death. Because these cells never died, they also never truly made room for novelty. Each bacterial mat was like a library where new books could only be added to shelves that were already completely full. Evolution had painted itself into a corner of its own success, creating life forms so perfectly adapted to their simple existence that they had lost the capacity to become anything else. The first problem was what scientists quietly call competitive exclusion, though in those ancient waters it played out like a very slow, very gentle form of cosmic musical chairs. The most successful bacteria would reproduce until they filled every available niche, and then they would simply continue. There was nowhere for new variations to establish themselves, no empty spaces for evolutionary experiments to unfold. It was like a garden where the first flowers to bloom would live forever, preventing any new species from ever taking root. Consider the mathematics of immortal reproduction for a moment. If each bacterium divides every few hours and none ever dies, the population grows exponentially without any natural check. Your ancestors were essentially playing a biological game where the score could only go up, never down, creating a kind of evolutionary inflation where more and more life competed for the same finite resources. The oceans were becoming crowded not with diversity, but with endless copies of the same successful designs. Perhaps even more profound was the problem of genetic stagnation. Without death to remove less optimal genetic combinations, and without sexual reproduction to shuffle genes in new ways, your ancestors were trapped in whatever genetic configuration had made them successful in the first place. They were like perfectly tuned instruments that could play one beautiful song endlessly, but could never learn a new melody. Evolution had become a broken record player, repeating the same genetic themes with stunning fidelity, but no capacity for variation. The beauty of this ancient predicament lies in how it perfectly set the stage for life's greatest innovation. Your immortal ancestors were unknowingly conducting the universe's most patient experiment in the relationship between permanence and progress. They were teaching the cosmos that even perfection, when maintained too long, becomes a kind of beautiful prison that ultimately limits the very life it seeks to preserve. Think of it like this. Imagine if the first human language had been so perfect that no one ever needed to develop new words, new expressions, new ways of communicating. That language might have been wonderfully stable, but it would also have prevented the poetry, the literature, the countless forms of artistic expression that emerge only when language is allowed to evolve, to change, to sometimes even fail in beautiful ways. Your bacterial ancestors had created the biological equivalent of such a perfect language, and it was precisely that perfection that would eventually require transcendence. The resource limitations in those ancient oceans began to create subtle pressures that would eventually crack open the shell of immortality. As bacterial populations grew without ever diminishing, they began competing not just for space, but for increasingly scarce nutrients. Picture vast bacterial continents, where cells in the center began to starve, while cells on the edges thrived, creating the first gradients of success and failure in life's history. These gradients were the earliest whispers of natural selection, the first quiet suggestions that perhaps not all cells needed to persist forever. Your ancestors were beginning to experience the cosmic truth that would eventually reshape all of existence. The understanding that limitation can be liberation, that boundaries can create rather than constrain possibilities. The immortal cells that faced starvation were inadvertently preparing the ground for life's most radical innovation. The idea that individual sacrifice might serve a greater collective purpose. In those crowded primordial waters, evolution was slowly learning one of its most important lessons, that diversity requires turnover. That novelty needs space to emerge, that the old must sometimes step aside to make room for the new. It was a lesson written in the patient mathematics of population dynamics, in the quiet desperation of cells competing for dwindling resources, in the first tentative experiments with genetic variation that would eventually lead to the profound complexity you embody today. And here you are, the living proof that this ancient problem found its solution. Every cell in your body carries the wisdom learned in those crowded seas, the deep knowledge that mortality is not life's failure, but its greatest success. Your finite existence is not a limitation imposed upon you, but a gift carefully crafted over billions of years, an inheritance of profound wisdom that allows you to be far more than your immortal ancestors could ever dream of becoming. Soon, we'll explore how life began its first tentative experiments with endings, how random accidents became purposeful programming, and how the invention of death became the foundation for everything beautiful and complex in your existence. But for now, simply rest in the knowledge that your mortality connects you to this vast story, this gentle epic of life, learning to let go. As we drift further into deep time, we encounter one of evolution's most beautiful accidents, the first random deaths that would eventually teach life the profound value of intentional endings. In those ancient seas, approximately 3 billion years ago, your ancestors began experiencing something entirely new in the cosmos, the possibility that existence might have boundaries, that even the most successful cells might sometimes simply stop. Picture these early deaths like autumn leaves falling from an eternal tree that had never known seasons. At first, they were purely accidental, cosmic hiccups in the smooth rhythm of immortal division. A cell might encounter a burst of radiation from the young, violent sun. Another might absorb a toxic mineral that disrupted its delicate internal chemistry. Some might simply malfunction during division, their copying mechanisms failing in ways that led not to new cells, but to cellular dissolution. These weren't planned endings, but random mechanical failures in the great machine of early life. Imagine the first cells that experienced death as confused librarians whose books suddenly began disappearing from their shelves. They had no framework for understanding why some of their community members simply stopped dividing, stopped responding, stopped participating in the endless dance of bacterial existence. Death was like a word in a language that hadn't been invented yet, an experience without meaning or context. But here's where the story becomes beautifully paradoxical in the way that only deep time can reveal. These random deaths, these cosmic accidents, were actually the universe's first tentative experiments with renewal. Each cell that died accidentally was creating a tiny space in the crowded bacterial communities, a small opening where something new might possibly emerge. Death was learning to be a gardener, though it didn't know it yet. Your ancestors who survived these early random deaths were unknowingly becoming the first witnesses to mortality, the first biological observers of life's new phenomenon. They were like the first beings to see lightning, unable to understand the electrical forces at work, but somehow sensing that something profound had entered their world. These surviving cells were developing the earliest forms of what we might call death consciousness, an awareness that existence had boundaries, even if those boundaries were still completely unpredictable. The profound beauty of this period lies in its innocent randomness. Death hadn't yet become a tool, a strategy, a biological solution to evolutionary problems. It was simply an event that sometimes happened, like weather in a world that was just learning about seasons. Your bacterial ancestors were experiencing the first gentle introduction to the concept that would eventually become life's greatest teacher, though they had no idea they were attending the universe's first mortality classroom. Natural selection, that patient cosmic editor, began to notice these random deaths and started making subtle annotations in the margins of life's story. Cells that were slightly more resistant to the environmental hazards that caused death began to have tiny advantages in the great lottery of survival. It was like a very slow, very gentle form of quality control, where the universe was beginning to learn which designs worked best under the new conditions that included occasional mortality. But the most profound aspect of these early deaths was how they began to change the mathematics of existence itself. In a world of pure immortality, every cell that ever lived would theoretically continue living forever, creating an exponentially growing population with no natural limits. But with even random, accidental death removing some cells from the equation, space began to open up for new possibilities, new genetic combinations, new evolutionary experiments. Think of it like this. If a library never removed any books, but kept adding new ones, it would eventually become so crowded that no one could find anything interesting. But if occasionally, randomly, some books disappeared, it would create not just physical space, but intellectual space for new kinds of stories, new genres, new ways of organizing knowledge. Your ancestors were living through life's transition from an impossibly crowded library to one with room for growth and change. The first cells to die randomly were, unknowingly, making a profound sacrifice for the future of complexity. They were like the first fallen logs in a forest, creating the cleared spaces where new kinds of plants could eventually take root. Without those early random deaths, the bacterial mats of your ancestral oceans might have remained frozen in immortal sameness forever, and the path that eventually led to your existence would never have been possible. Your modern cells still carry genetic echoes of this ancient period when death was purely accidental. The DNA repair mechanisms in your body, the cellular defenses against radiation and toxins, the backup systems that protect your genetic information, all of these are evolutionary inheritances from ancestors who survived the cosmic lottery of random mortality. You exist because your lineage learned to navigate a world where death had become possible, even if it wasn't yet purposeful. There's something deeply moving about contemplating those first accidental deaths in the context of your own mortality. Every cell in your body is descended from survivors of that ancient transition, carriers of genetic wisdom learned when death was still a stranger to life. The fear of mortality that sometimes keeps you awake at night, the precious sense that your time is limited and therefore valuable. These feelings connect you directly to those ancient bacterial communities that first encountered the mystery of ending. As we prepare to explore how life began to transform random death into purposeful mortality, rest in the knowledge that your ancestors survived the universe's first experiments with finitude. They navigated the transition from a world where death was impossible to one where it was merely accidental, learning lessons about resilience and adaptation that still protect you today. Soon, we'll discover how these random endings became the foundation for the most sophisticated biological program ever developed, the program of intentional mortality that makes your complex existence possible. Let's drift forward in deep time to one of evolution's most elegant innovations. A moment roughly 2 billion years ago, when your ancestors made a discovery that would forever change the relationship between life and death. In the quiet depths of ancient oceans, some cells began experimenting with something that seemed almost counterintuitive. They started sharing their genetic material with each other before dividing, creating offspring that were no longer perfect copies, but beautiful combinations. This was the gentle birth of sexual reproduction, though not as you know it today. Imagine it like two ancient libraries deciding to exchange some of their books before creating new branch libraries. Instead of each new library being an exact copy of its parent, these new libraries became unique combinations, carrying the best volumes from both sources while leaving some books behind forever. It was life's first experiment with genetic collaboration, with the radical idea that variation might be more valuable than perfection. Picture your bacterial ancestors as they encountered this revolutionary process for the first time. Some cells would approach each other and form temporary connections, tiny bridges through which genetic material could flow like whispered secrets shared between old friends. Through a process called horizontal gene transfer, they would exchange pieces of their DNA, creating new genetic combinations that had never existed before in the history of the universe. It was like cosmic poetry written in the language of nucleotides, where old verses were combined to create entirely new forms of biological verse. The profound implication of this genetic mixing was that parent cells were no longer creating perfect immortal copies of themselves. Instead, they were contributing to the creation of something genuinely new, offspring that carried genetic combinations their parents had never possessed. For the first time in life's history, children were different from their parents not by accident, but by design. It was evolution's first intentional step away from the immortality of endless copying toward the creative mortality of limited inheritance. This innovation created what we might call evolutionary time pressure, the first gentle urgency in biological history. If a cell's offspring were going to be different from itself, carrying only some of its genetic heritage, then that cell's unique combination of genes would only persist for its own lifespan. The era of true genetic immortality was beginning to end, replaced by a more complex form of continuity where information could persist across generations, even as individual carriers came and went. Your ancestors were learning the first lesson about genetic mortality, that sometimes the best way to preserve something precious is to let it change. Like a storyteller who knows that each telling of a tale will be slightly different, they began to understand that genetic information could remain alive across time, not by staying exactly the same, but by being lovingly adapted and recombined with each new generation. The emergence of sexual reproduction marked the first time in cosmic history that life chose complexity over simplicity, variation over uniformity, creative risk over immortal safety. Your ancestors were making an unconscious but profound philosophical choice, trading the guarantee of genetic persistence for the possibility of genetic improvement. They were becoming the universe's first venture capitalists, investing their genetic heritage in uncertain but potentially revolutionary new combinations. Think about the beautiful irony of this transition. Sexual reproduction introduced a form of death that was actually more profound than physical death, genetic death. Even if a parent cell survived the reproductive process, its unique genetic combination would die with it, never to be exactly replicated again. The parent's genetic legacy would continue, but only as scattered pieces in the mosaic of its offspring's inheritance. It was like a master painter destroying their greatest work to provide pigments for their students' creations. This genetic mortality created the first evolutionary pressure toward innovation. Cells that could produce the most successful offspring, even if those offspring were genetically different from themselves, began to dominate bacterial communities. Natural selection was learning to think beyond individual survival, beginning to appreciate the profound wisdom of biological systems that could improve themselves by allowing their components to change and even disappear. Your bacterial ancestors were pioneering what we might call conscious genetic sacrifice. Though, of course, they had no awareness of what they were doing. They were developing the first biological programs that prioritized the success of genetic information over the persistence of individual genetic combinations. It was evolution's first lesson in letting go, in trusting that change could be preservation rather than loss. The fascinating complexity of early sexual reproduction also introduced the first biological clocks into your ancestral lineage. Cells that engaged in genetic exchange had to coordinate their activities, creating rhythms and cycles that hadn't existed in the purely asexual world of immortal division. These rhythms were like the first biological music, gentle temporal patterns that would eventually evolve into all the cycles that govern your life today, from your sleep rhythms to your heartbeat, to the seasonal changes in your mood and energy. As sexual reproduction became more sophisticated, your ancestors discovered that genetic death could be a form of genetic immortality. By sacrificing their individual genetic combinations, they were contributing to a larger genetic pool that could persist and evolve across vast spans of time. They were learning that true immortality lay not in individual persistence, but in the ability to contribute to an ongoing genetic conversation that could continue indefinitely, adapting and improving with each new generation. And here you are, the magnificent result of billions of years of genetic conversation, a living library containing carefully curated selections from millions of ancestral genetic collections. Your DNA is like a vast anthology of genetic poetry, where each gene represents a verse that survived because it contributed something valuable to the ongoing story of life. Your mortality allows you to add your own unique chapters to this epic, ensuring that the genetic conversation continues to evolve and improve long after your individual contribution has been lovingly integrated into the larger narrative of life on Earth. As we venture deeper into the elegant corridors of evolutionary time, we arrive at one of life's most sophisticated innovations, the development of programmed aging. Roughly 1.5 billion years ago, your ancestors made a discovery that seems almost paradoxical. They learned how to build their own obsolescence directly into their genetic architecture. It was like installing a gentle, cosmic timer that would ensure each generation had a natural conclusion, making room for the next chapter in life's ongoing story. Imagine your early eukaryotic ancestors as master clockmakers, crafting not just the mechanisms of life, but also the delicate mechanisms of life's ending. They began developing what scientists call senescence genes, specialized genetic programs whose sole purpose was to gradually slow down and eventually halt the cellular processes that maintained life. It was evolution's most counterintuitive innovation. Genes whose success was measured not by how well they preserved life, but by how gracefully they could bring it to a close. Think of these senescence genes like wise gardeners embedded within your cellular architecture. Just as a good gardener knows that pruning is essential for a plant's health, these genetic programs learn to gradually reduce cellular efficiency over time, creating space for new growth and preventing any single organism from monopolizing resources indefinitely. Your ancestors were developing the biological equivalent of term limits, ensuring that even the most successful individuals would eventually step aside for the next generation. The first programmed aging mechanisms were remarkably subtle, like slowly dimming lights that would take decades or even centuries to fade completely. Early eukaryotic cells began developing genetic switches that would gradually reduce their ability to repair damage, to produce energy, to maintain their complex internal structures. It was like installing a gentle countdown timer that would tick so slowly it would be barely noticeable from day to day. But over the vast span of an organism's lifetime, it would ensure a natural transition from growth to decline to peaceful conclusion. Consider the profound genetic wisdom required for this innovation. Your ancestors had to develop biological programs that could distinguish between immediate cellular damage that needed to be repaired quickly and long-term cellular aging that needed to proceed on schedule. They were learning to build genetic calendars, molecular scheduling systems that could track the passage of time and adjust cellular behavior accordingly. It was like developing internal clocks that could measure not just days and seasons, but entire lifespans. The beauty of programmed senescence lies in its gentle inevitability. Unlike random accidental death, which could strike at any moment without warning, genetic aging created predictable life cycles that allowed organisms to plan their biological activities around their own mortality. Cells could invest energy in growth during their youth, reproduction during their prime, and then gradually wind down their activities as their genetic timers approached their natural conclusion. It was evolution's first experiment with biological time management, with the idea that mortality could be not just accepted, but actively scheduled. The development of senescence genes also solved one of evolution's most elegant optimization problems: how to balance individual success with species success. Cells that lived too long might become evolutionary dead ends, perfectly adapted to outdated conditions, but unable to respond to environmental changes. But cells with programmed aging could contribute their genetic wisdom to the next generation and then gracefully step aside, allowing their offspring to inherit their strengths while developing new adaptations for changing conditions. Your ancestors were learning that genetic immortality and individual immortality were actually different concepts, and that you could preserve the first by releasing attachment to the second. It was like discovering that the best way to keep a flame burning forever was not to protect a single candle from ever going out, but to ensure that each candle could light new candles before it naturally extinguished itself. The flame could be eternal, even if each individual candle was deliberately temporary. Perhaps most remarkably, Programmed aging allowed your ancestors to begin experimenting with different lifespans for different biological strategies. Some lineages developed genetic programs that aged quickly, allowing rapid turnover and fast adaptation to changing conditions. Others programmed longer lifespans, creating more stable populations that could weather environmental fluctuations. It was like biological jazz, where different species were learning to play with different tempos while still maintaining harmony within the larger ecosystem. The senescence genes that your ancestors developed during this period are still active in your body today, still quietly managing the delicate balance between cellular maintenance and cellular aging. Your immune system's gradual decline with age, the way your skin changes texture over decades, the gradual slowing of your metabolic processes. All of these are the gentle expression of genetic programs that your ancestors developed billions of years ago. You are living proof that death can be not just natural, but beautifully programmed into the very essence of complex life. Consider the profound patience required for evolution to develop these aging mechanisms. Natural selection had to operate across millions of generations, gradually fine-tuning genetic switches that would only activate decade into an organism's lifespan. It was like composing music where some notes wouldn't be heard until the very end of a very long song, requiring composers who could think in evolutionary time rather than individual time. The emergence of programmed senescence also marked the first time that death became predictable enough to influence behavior. Organisms could begin to sense their own aging and adjust their activities accordingly, investing more energy in reproduction as they approached their genetic expiration date. It was evolution's first exploration of mortality awareness, the beginning of life's long journey toward consciousness of its own finite nature. And here you are, carrying within your cells these ancient genetic timepieces, these molecular calendars that connect your personal aging process to billions of years of evolutionary innovation. Your mortality is not a bug in your biological programming, but a carefully refined feature, a sophisticated genetic inheritance that allows you to participate in life's ongoing experiment with temporal existence. Every gray hair, every laugh line, every sign of your gentle aging is a visible expression of genetic wisdom that took eons to perfect. As we continue our gentle journey through evolutionary time, we encounter one of life's most beautiful and profound innovations, the development of programmed cell death, or apoptosis. Around 1.2 billion years ago, your ancestors discovered something that seems almost mystical in its wisdom. They learned how to create cells that would voluntarily end their own lives for the greater good of the organism they belonged to. It was evolution's first lesson in conscious sacrifice, in the profound truth that individual death could serve collective life. Picture apoptosis like a gentle form of cellular Buddhism, where individual cells develop the wisdom to recognize when their continued existence might harm the larger community they serve. These cells learned to read molecular signals that indicated when they had become damaged, infected, or simply unnecessary, and in response, they would activate their own death programs with a kind of biological grace that still takes our breath away. They were becoming the first martyrs in the service of complex life, voluntarily dissolving themselves so that you could exist. The mechanics of apoptosis are like watching a cell perform its own peaceful funeral ceremony. When a cell receives the molecular signals indicating it's time to die, it begins an intricate dance of self-dismantling that is both systematic and beautiful. The cell carefully packages its contents, breaks down its own proteins, fragments its DNA, and creates tiny membrane-bound parcels that neighboring cells can safely absorb and recycle. It's like watching someone thoughtfully pack their belongings before moving away, ensuring that nothing valuable is wasted and everything useful is passed on to those who remain. Your ancestors who first developed apoptosis were solving one of multicellular life's greatest challenges: how to create biological communities where individual members could sacrifice themselves for collective benefit. Think of it like a choir, where individual singers learned to stop singing precisely when their voices were no longer needed for the harmony, trusting that their silence would make the overall music more beautiful rather than destroying it. This innovation required a complete revolution in cellular consciousness, if we can call it that. Your ancestral cells had to develop molecular sensing mechanisms that could distinguish between damage that should be repaired and damage so severe that the cell should eliminate itself entirely. They were learning to become biological physicians who could diagnose not just illness, but the point at which continued treatment would harm the patient more than death would help the community. The first cells to master apoptosis were like biological bodhisattvas, achieving a form of enlightenment where individual survival became secondary to collective flourishing. They developed genetic programs that could override their basic survival instincts, actively triggering their own destruction when molecular signals indicated that their death would benefit the larger organism. It was evolution's first exploration of altruistic mortality, of death as a form of love rather than failure. The profound beauty of apoptosis becomes even more apparent when you consider how it enabled the first truly complex multicellular organisms. Before programmed cell death, multicellular communities were like cities where no building could ever be demolished, where broken infrastructure had to be worked around rather than replaced. But with apoptosis, your ancestors could begin building biological cities where damaged or unnecessary structures could be efficiently removed and replaced, creating space for growth, adaptation, and repair. Consider how this innovation revolutionized healing and development. When you cut your finger today and watch it heal, you're witnessing billions of years of apoptotic wisdom in action. Damaged cells along the wound edge receive molecular signals telling them to eliminate themselves, clearing the way for healthy cells to divide and fill the gap. Meanwhile, other cells receive signals to temporarily increase their division rate, creating new tissue to replace what was lost. It's like a biological construction crew, where some workers know exactly when to tear down damaged structures, while others know exactly when to begin building replacements. Your embryonic development was entirely dependent on this ancient wisdom of cellular sacrifice. When you were developing in the womb, apoptosis carefully sculpted your body by removing the cells that formed the webbing between your fingers and toes, creating the individual digits you use today. Other apoptotic programs removed the tail structure that briefly appeared during your early development, carved out the chambers of your heart, and shaped the intricate folds of your brain. You were literally sculpted by death, your body emerging from a biological block of living marble through the precise removal of unnecessary cells. The immune system's mastery of apoptosis represents perhaps evolution's most sophisticated use of programmed cell death. Your white blood cells are trained killers in the most beautiful sense, capable of inducing apoptosis in infected cells, cancer cells, or any cells that threaten the stability of your biological community. When a virus infects one of your cells, your immune system can send molecular signals that convince the infected cell to trigger its own death program, sacrificing itself to prevent the infection from spreading. It's like having cellular citizens so devoted to their community that they will voluntarily remove themselves, rather than become a threat to their neighbors. Perhaps most profound is how apoptosis connects your daily experience to this ancient evolutionary wisdom. Every time you sleep, millions of your brain cells use apoptotic-like processes to clean house, removing damaged proteins and clearing metabolic waste that accumulated during your waking hours. Your dreams themselves occur during a time when your brain is conducting its own gentle form of cellular renewal, using death-like processes to maintain the health of your consciousness. The stress you feel during difficult times actually activates ancient apoptotic pathways, preparing your cells to sacrifice themselves if necessary to protect your overall health. Even your emotions are connected to these primordial death programs. Your capacity for grief and loss reflecting the deep cellular wisdom that understands sacrifice as a form of love, ending as a form of beginning. And here you are, every moment of your existence made possible by the countless cellular deaths occurring within your body right now. Millions of your cells are voluntarily ending their lives as you listen to these words, creating space for new cells, removing damage, maintaining the complex biological symphony that is your living presence. You are not just mortal, you are a masterpiece of mortality, a living celebration of death's profound service to life. As we continue our contemplative drift through deep time, we arrive at a period roughly 800 million years ago, when your ancestors made perhaps their most poetic discovery, that death could be not an ending but a transformation, not a loss but a renewal. In the ancient seas, life began developing its first sophisticated cycles, biological rhythms where death and rebirth became partners in an eternal dance of regeneration. Picture your early multicellular ancestors as they first learned to practice what we might call resurrection biology, the ability to allow parts of themselves to die completely while retaining the capacity to regrow those same parts from remaining tissue. Like trees learning to shed their leaves each autumn with complete confidence that spring would bring new growth. These organisms developed the profound trust required to let go of pieces of themselves, knowing that renewal was not just possible but inevitable. Consider the first organisms that developed true regenerative abilities, creatures that could lose entire limbs or organs and simply regrow them over time. Your ancestors were becoming biological phoenixes, capable of emerging from partial destruction, not just intact, but often improved. They were learning that death, when approached with the right biological wisdom, could become a tool for renewal rather than an obstacle to continued existence. It was like discovering that breaking could be a form of healing, that destruction could be a form of creation. The genetic programs that enabled this regeneration required a complete reconceptualization of what it meant to be an individual organism. Your ancestors had to develop stem cell populations, special clusters of cells that remained perpetually young and undifferentiated, capable of becoming any type of cell the organism might need. These stem cells were like biological time travelers, carrying the genetic memory of youth through an organism's entire lifespan, ready to spring into action whenever regeneration was needed. Think of these early regenerative organisms as living laboratories for experimenting with the relationship between death and renewal. They were developing biological philosophies that would later influence everything from your body's ability to heal wounds to your hair's capacity to grow continuously throughout your life. They were your first teachers in the profound truth that sometimes the best way to preserve something is to allow it to die and be reborn rather than trying to maintain it indefinitely in its original form. The seasonal cycles that began emerging during this period introduced your ancestors to perhaps the most beautiful form of death as renewal, the cyclical mortality that allows organisms to survive harsh periods by allowing non-essential parts of themselves to die temporarily. Like deciduous trees that sacrifice their leaves to survive winter, many organisms learn to enter states of partial death during difficult environmental conditions, maintaining only their most essential functions while allowing the rest of their biology to shut down and await better times. This cyclical approach to mortality taught your ancestors perhaps their most important lesson about the relationship between death and time. They learned that death didn't have to be permanent to be useful, that temporary endings could serve biological purposes just as effectively as permanent ones. It was like discovering that sleep could be a form of daily death that made waking life more vibrant. That rest could be a form of renewal that made activity more effective. The hibernation patterns that some of your ancestors developed represent perhaps the most sophisticated early exploration of death as renovation. During hibernation, metabolism slows to almost imperceptible levels. Body temperature drops, heartbeat becomes barely detectable, and many cellular processes essentially shut down. From the outside, a hibernating organism appears to be practicing death, but from the inside, it's conducting perhaps the most elegant maintenance program in biological history, using the downtime to repair damage, clear waste, and prepare for renewed activity. Your ancestors were also learning that regeneration could be improved by making it cyclical rather than constant. Instead of trying to maintain every cell and tissue indefinitely, They developed biological rhythms where different parts of the organism would die and regenerate on different schedules. Your hair and nails grow continuously because they die and are replaced constantly. Your skin regenerates itself completely every few weeks. Your digestive system replaces its lining every few days. You are not a static being, but a dynamic river of renewal, where death and rebirth occur so frequently and so smoothly that you rarely notice the constant turnover. The profound wisdom of this cyclical mortality is that it allows your body to stay young even as you age. While your overall organism accumulates years and experiences, many of your individual cells are actually quite young, having been born recently through the death and regeneration cycles your ancestors perfected hundreds of millions of years ago. You are simultaneously ancient and newborn, carrying genetic wisdom from deep time while maintaining cellular freshness through ongoing renewal. Your circadian rhythms, the daily cycles that govern your sleep and waking, are deeply connected to these ancient patterns of cyclical death and renewal. Every night when you sleep, your brain activates, cleaning processes that are remarkably similar to the cellular death and renewal cycles your ancestors developed. During deep sleep, your glial cells actually shrink, creating spaces for cerebrospinal fluid to flow through and wash away the metabolic waste that accumulated during your waking hours. It's like your brain practices a gentle form of death each night, clearing away the accumulated debris of consciousness so you can wake refreshed and renewed. The emotional cycles you experience, the way your mood and energy naturally ebb and flow, are also connected to this ancient wisdom of cyclical mortality. Your ancestors learned that sustainable life required not constant high activity, but rhythmic alternation between periods of growth and periods of rest, between times of expansion and times of consolidation, between seasons of abundance and seasons of conservation. And here you are, a living symphony of these ancient cycles, your heartbeat marking time like a biological metronome, your breathing creating its own rhythm of renewal, your sleep providing nightly resurrection, your cellular turnover ensuring that you are constantly dying and being reborn at the microscopic level. You are not just mortal, you are cyclically immortal, participating in the same patterns of death and renewal that your ancestors developed as their first experiments with the profound mystery of endings that lead to beginnings. As we drift forward through the vast corridors of evolutionary time, we arrive at approximately 600 million years ago, when your ancestors began composing perhaps the most sophisticated biological symphony ever attempted, the coordination of specialized cellular death within complex multicellular organisms. This was when life learned that different types of cells could die in different ways, at different times, for different purposes, creating a rich tapestry of mortality that enabled unprecedented biological complexity. Think of your early multicellular ancestors as they began developing what we might call death expertise, specialized cellular lineages that became masters of particular types of ending. Some cells learned to die quickly and efficiently to fight infections. Others learned to die slowly and gracefully to make room for growth. Still others learned to die in precisely timed waves to sculpt developing organs and tissues. It was like evolution developing a comprehensive curriculum in the art of dying, with different cell types mastering different aspects of mortality's service to life. Imagine the extraordinary coordination required for this cellular specialization of death. Your ancestors had to develop communication systems that could tell bone cells when to dissolve themselves to allow muscles to attach properly. That could instruct nerve cells when to eliminate unnecessary connections to refine neural pathways. That could guide immune cells when to sacrifice themselves to protect against infection. It was like orchestrating a vast biological ballet where thousands of different dancers had to know not just when to move, but when to gracefully exit the stage. The development of specialized tissues brought with it specialized forms of mortality that still operate within your body today. Your bone tissue, for example, is in constant flux, with cells called osteoclasts, continuously dissolving old bone material, while osteoblasts create new bone to replace it. Your skeleton is completely renewed every 7 to 10 years through this elegant dance of specialized death and rebirth. You are literally wearing a different skeleton than you had a decade ago, though the shape and structure remain beautifully consistent. Your nervous system represents perhaps the most sophisticated example of specialized cellular death in service of complexity. During your brain's development, you initially formed far more neural connections than you could possibly use. Your ancestors had learned that the brain could be sculpted not just by growing new connections, but by carefully eliminating unnecessary ones through programmed cell death. The neurons that died during your brain's development were like master sculptors, removing themselves to reveal the elegant neural architecture that enables your consciousness, your memory, your capacity for complex thought. Consider the profound genetic wisdom required to coordinate these different types of specialized death. Your ancestors had to develop genetic programs that could track not just the age of individual cells, but their function, their location, their relationship to surrounding tissues, and their contribution to the organism's overall health. They were creating biological civil services where different departments had different retirement ages, different pension programs, different protocols for training their replacements. Your digestive system showcases another beautiful example of specialized cellular mortality, with different regions programmed for different death schedules based on the harsh conditions they must endure. The cells lining your stomach, constantly exposed to acid that could dissolve metal, replace themselves every few days through precisely choreographed death and renewal cycles. Meanwhile, the cells in your small intestine, working in slightly gentler conditions, operate on a weekly replacement schedule. Each tissue has learned its own perfect rhythm of death and renewal, like instruments in an orchestra where each section knows exactly when to fade out and when to come back in. The evolution of specialized death also enabled your ancestors to develop true tissue repair capabilities that go far beyond simple regeneration. When your liver is damaged, hepatocytes, liver cells, can sacrifice themselves to wall off the damage, while nearby cells shift into rapid reproduction mode to replace the lost tissue. When your heart muscle is injured, cardiac cells use specialized death programs to prevent the spread of damage, while activating stem cells to begin repair processes. These are like biological emergency response teams, where some members know how to contain disasters, while others know how to rebuild afterwards. Perhaps most remarkably, your ancestors learned to use specialized cell death as a form of biological memory. Your immune system remembers past infections, partly through the strategic death of immune cells that have encountered specific pathogens. When these cells die, they leave behind molecular signatures that teach other immune cells how to respond more effectively to future encounters with the same threats. It's like a library where books sacrifice themselves to create more valuable reference materials, where individual knowledge dies to become collective wisdom. The coordination of specialized death also enabled your ancestors to develop the first true biological aging processes, where different tissues age at different rates according to their function and importance. Your brain cells are programmed to last your entire lifetime, dying very rarely and slowly. Your blood cells are programmed to live only a few months, dying and being replaced constantly to maintain the flexibility and freshness needed for efficient transport. Your reproductive cells follow yet another schedule, with some remaining dormant for decades, while others mature and die in monthly cycles. Your skin provides a beautiful daily demonstration of specialized death in service of protection. The outermost layer of your skin consists entirely of dead cells, keratinocytes that sacrifice themselves to form a protective barrier against the outside world. These dead cells shield the living cells beneath them, taking the brunt of environmental damage, while slowly wearing away and being replaced by new sacrificial cells rising from below. You are literally armored in the loving sacrifice of your own dead cells, protected by their willingness to die in your service. The profound truth that emerges from contemplating specialized cellular death is that your complexity exists only because millions of your cells know how to die with precision and purpose. You are not just a collection of living cells, but a community where living and dead cells work together in exquisite harmony. Your existence is supported by an ongoing conversation between life and death that has been refined over hundreds of millions of years. And here you are, the conscious witness to this extraordinary collaboration, able to contemplate the very cellular sacrifices that make your contemplation possible. Every thought you think emerges from neural networks that were sculpted by programmed cell death. Every breath you take is enabled by lung tissue that renews itself through precisely timed cellular sacrifice. You are evolution's greatest experiment in conscious mortality, a being complex enough to understand and appreciate the deaths that enable your life. Let us pause in our journey through deep time to contemplate one of evolution's most elegant discoveries: how mortality became the great accelerator of adaptation. Around 500 million years ago, as complex life began flourishing in ways the universe had never seen before, your ancestors learned that death was not evolution's enemy, but its closest collaborator, the force that could transform gradual change into rapid innovation, turning millions of years of adaptation into mere thousands. Picture mortality as evolution's gentle but efficient editor, constantly removing the drafts that no longer serve the story while making space for new chapters to emerge. In a world of immortal organisms, evolution could only work by slowly modifying existing individuals over vast spans of time. But with programmed death creating regular turnover, evolution gained the ability to compare different genetic strategies across generations, selecting the most successful combinations and discarding the less effective ones with unprecedented speed. Think of how a master artist might improve their work if they could paint a new canvas every day rather than being forced to continuously modify the same painting for decades. Your mortal ancestors gave evolution this kind of creative freedom, providing fresh biological canvases with each new generation, while ensuring that the lessons learned from previous generations weren't lost but carefully preserved in genetic memory. Death became evolution's gift of creative acceleration, the biological mechanism that transformed gradual improvement into revolutionary innovation. Your ancestors during this period were participating in perhaps the most intense creative collaboration in cosmic history, where mortality and adaptation worked together to generate unprecedented biological diversity. Species that had taken millions of years to emerge in the immortal world could now appear in thousands of years. New adaptations that might have required eons to spread through immortal populations could now sweep through mortal populations in mere centuries. It was like biological jazz improvisation, with a rhythm of death and birth created space for evolutionary music that had never been played before. The Cambrian explosion, that remarkable period when complex life forms appeared seemingly overnight in geological terms, was directly enabled by this partnership between mortality and rapid adaptation. Your ancestors had learned to use death as an evolutionary tool, so effective that it could generate new species faster than the fossil record could even preserve them. They were participating in a biological renaissance where mortality had become the great enabler of novelty, the force that could transform gradual change into explosive creativity. Consider the mathematical beauty of this acceleration. In immortal populations, beneficial mutations would have to compete with established individuals for resources and space, often taking millions of years to become dominant. But in mortal populations, beneficial mutations could quickly become common simply by being passed to offspring while the previous generation aged and died naturally. Death had become evolution's fast-forward button, allowing genetic innovations to spread through populations at unprecedented speed. The acceleration of evolution through mortality also enabled your ancestors to develop what we might call adaptive intelligence, the ability to respond to environmental challenges, not just through individual learning, but through genetic learning that could be passed to future generations. Each generation became a biological experiment where successful adaptations were preserved through reproduction, while unsuccessful ones were gently removed through natural death. It was like having a genetic research laboratory where thousands of experiments could run simultaneously, with mortality serving as the patient but efficient quality control system. Your ancestors were discovering that short lifespans could actually lead to longer species survival. Organisms with brief individual lifespans could evolve so quickly in response to environmental changes that they could persist through conditions that would have driven immortal species to extinction. It was a profound biological paradox that accepting individual mortality could be the key to achieving species immortality, that letting go of personal permanence could be the secret to genetic persistence across vast spans of time. Think about how this principle continues to operate in your own genetic lineage. The rapid evolution of your immune system, constantly adapting to new pathogens through the birth and death of immune cells, demonstrates this ancient wisdom in action. Your immune cells live briefly but intensely, learning about new threats and passing that information to subsequent generations of immune cells through molecular memory systems. The mortality of individual immune cells enables the immortality of your body's defensive knowledge. The relationship between generation time and evolutionary speed that your ancestors discovered explains why organisms with shorter lifespans often evolve more quickly than those with longer lifespans. Bacteria and viruses, with their rapid reproduction and death cycles, can evolve in months or years. Your ancestors learned to balance lifespan length with a need for adaptive flexibility, developing lifespans long enough to allow for learning and reproduction, but short enough to enable genetic innovation across reasonable timescales. Your human lifespan represents a beautiful optimization of this ancient balance. You live long enough to accumulate wisdom, develop complex skills, form deep relationships, and contribute meaningfully to your community's knowledge. But you also live briefly enough that your species can continue evolving, adapting to new challenges, responding to environmental changes that might require genetic solutions that take several generations to implement. Your mortality is perfectly calibrated to serve both individual flourishing and species adaptation. The cultural evolution that humans have developed represents perhaps the ultimate expression of mortality-accelerated adaptation. Just as your biological ancestors used death to speed up genetic evolution, your cultural ancestors learned to use individual mortality to accelerate the evolution of ideas, technologies, and social systems. Each generation of humans can build upon the knowledge left by the previous generation while also questioning its assumptions and developing new approaches. The death of individuals prevents cultures from becoming frozen in outdated ideas, just as the death of organisms prevents species from becoming trapped in outdated adaptations. And here you are, participating in both forms of accelerated evolution simultaneously. Your biological mortality ensures that your species remains genetically flexible and responsive to environmental challenges. Your cultural mortality ensures that human knowledge and wisdom continue to evolve, with each generation adding new insights while allowing outdated ideas to fade gently away. You are evolution's greatest experiment in conscious acceleration, able to understand and appreciate the very mortality that makes your adaptive intelligence possible. As we continue our gentle exploration through the epochs of evolutionary innovation, we encounter one of life's most sophisticated applications of targeted mortality: the development of immune systems that could distinguish between self and other, between friend and foe, between cells that deserved protection and cells that required elimination. Roughly 450 million years ago, your ancestors began developing the biological equivalent of wise guardians, specialized cells whose primary purpose was to identify threats and eliminate them through precisely controlled death. Picture your early vertebrate ancestors as they first developed adaptive immune systems, biological communities that could learn and remember. Unlike the simple chemical defenses of earlier organisms, these new immune systems were like having an internal biological intelligence service, complete with scouts, analysts, memory keepers, and specialized elimination teams. Your ancestors were creating the first biological military organizations where death was used not as a weapon of conquest, but as a tool of protection, where killing became a form of healing. The T cells that your ancestors developed represent, perhaps, evolution's most elegant solution to the problem of biological security. These remarkable cells learn to patrol your body like wise sentinels, constantly sampling the molecular signatures of other cells to ensure they belong to your biological community. When they encountered cells that had been infected by viruses or transformed by cancer, they could induce those cells to trigger their own death programs, eliminating threats through what amounts to molecular persuasion rather than brute force destruction. Think of this process like having internal diplomatic corps that could convince foreign agents to surrender peacefully rather than having to destroy them violently. Your T cells approach infected cells and present them with molecular evidence of their compromise, essentially showing them documentation that proves they've become a threat to the community. In response, the infected cells activate their own apoptotic programs, dying quietly and efficiently while minimizing damage to surrounding healthy tissue. Your B cells developed an even more sophisticated approach to protective mortality, learning to create molecular weapons called antibodies that could mark specific threats for elimination. But here's where the story becomes beautifully complex. These B cells sacrifice their own longevity to become antibody factories, transforming themselves into plasma cells that live briefly but intensely, producing vast quantities of protective molecules before dying from the exhaustion of their own productivity. They are like biological artisans who dedicate their entire brief existence to crafting the molecular tools needed to protect your larger community. The memory cells that your immune system creates represent perhaps the most poetic use of specialized death for long-term protection. When your immune system encounters a new pathogen, some immune cells sacrifice their normal longevity to become long-lived memory cells, biological archivists that remember the molecular signature of threats for decades. When you receive a vaccination, you're actually creating new memory cells that will spend their extended lifespans quietly waiting, ready to trigger rapid protective responses if they ever encounter their specific threat again. The autoimmune processes that occasionally affect modern humans reveal both the power and the complexity of these ancient death-based protection systems. Sometimes your immune cells make mistakes, identifying healthy tissue as foreign and triggering protective death programs against your own cells. While these conditions can be challenging, they also demonstrate the extraordinary vigilance of immune systems that have been refined over hundreds of millions of years to err on the side of protection rather than risk allowing truly dangerous cells to persist. Your ancestors also developed perhaps the most sophisticated biological recycling systems ever invented, specialized cells called macrophages that serve as both undertakers and recyclers for your cellular community. These remarkable cells can recognize and consume cells that have died through apoptosis, breaking them down into useful components that can be redistributed to healthy cells. They are like biological composters, transforming cellular death into nutrients for continued life, ensuring that nothing valuable is wasted in the constant turnover of your tissues. The inflammatory responses that your immune system triggers during infection represent another elegant application of controlled death in service of healing. When tissues are damaged or infected, your immune system deliberately triggers localized cell death to create a biological firebreak, sacrificing some healthy cells to prevent infection from spreading, while simultaneously calling in specialized repair cells to begin reconstruction. It's like a controlled burn in a forest, where small intentional destruction prevents larger accidental destruction while preparing the ground for new growth. Your fever response demonstrates how your ancestors learned to use temporary near-death states as healing tools. When your body temperature rises during illness, you're activating ancient genetic programs that create an internal environment where your healthy cells can just barely survive while pathogenic organisms cannot. It's like your ancestors learned to walk right up to the edge of death as a therapeutic strategy, using mortality's proximity as a tool for eliminating threats while maintaining just enough biological function to recover once the threat has passed. The lymphatic system that your ancestors developed represents perhaps the most elegant integration of death and circulation ever achieved. This parallel circulatory system serves partly as a highway for immune cells and partly as a waste management system for the products of cellular death. Through your lymph nodes, specialized cells process the molecular remains of dead cells, sorting useful materials for recycling while identifying potential threats that require additional immune attention. It's like having a biological postal service where dead cells mail their contents to processing centers that can determine what should be preserved and what should be eliminated. Your daily immune maintenance demonstrates how these ancient death-based protection systems continue to operate during health as well as illness. Right now, as you listen to these words, immune cells throughout your body are identifying and eliminating cells that have accumulated too much damage to function properly. As we drift through the changing seasons of evolutionary time, we arrive at approximately 300 million years ago, when your ancestors began discovering one of mortality's most beautiful applications, the ability to synchronize death and renewal with the great cosmic rhythms that govern our planet. During this period, life learned to read the subtle signals of Earth's orbital dance around the sun, developing biological calendars that could predict seasonal changes and prepare for them through carefully orchestrated cycles of partial death and resurrection. Imagine your early mammalian ancestors as they first learned to practice what we might call seasonal mortality, the profound ability to allow large portions of their biology to die temporarily during harsh seasons while preserving just enough life to enable complete renewal when conditions improved. Hibernation represents perhaps evolution's most sophisticated experiment with voluntary near-death, a biological state so close to dying that early naturalists often couldn't distinguish between hibernating animals and dead ones. Think of hibernation like a master class in the art of strategic dying. Your hibernating ancestors learned to slow their heartbeats to just a few beats per minute, to lower their body temperature until they were barely warmer than their surroundings, to reduce their breathing to almost imperceptible levels, and to shut down most of their organ systems while maintaining just enough cellular activity to preserve the possibility of awakening. They were becoming biological sleeping beauties, capable of practicing death so convincingly that they could remain in that state for months while using almost no energy at all. The genetic programming required for successful hibernation represents some of the most complex mortality management ever developed. Your ancestors had to create biological systems that could gradually shut down non-essential functions in precisely the right order, ensuring that each system could be safely deactivated without triggering the permanent death programs that would end hibernation permanently. It was like learning to dismantle a complex machine so carefully that every piece could be perfectly reassembled months later, with all connections restored and all functions operating normally. Consider the profound trust required for this seasonal mortality. Your hibernating ancestors had to develop the biological equivalent of faith, trusting that their carefully orchestrated near-death would indeed lead to resurrection rather than permanent ending. They were gambling their lives on genetic programs that promised spring awakening, betting everything on biological alarm clocks that wouldn't ring for months. It was perhaps the most beautiful expression of mortality, as cooperation with natural cycles rather than resistance to them. The migration patterns that many of your ancestors developed represent another form of seasonal mortality, where organisms learn to let their connection to specific places die temporarily so they could follow the resources and conditions they needed for survival. Arctic terns, descended from your distant vertebrate cousins, still practice this form of geographical death and rebirth, allowing their relationship to summer breeding grounds to die each autumn so they can be reborn into Antarctic summer feeding grounds, following eternal summer around the planet through cyclical abandonment of place. The deciduous trees that emerged during this era developed perhaps the most visible and poetic form of seasonal death, learning to sacrifice their leaves each autumn in a spectacular display of mortality as preparation. These trees discovered that by allowing their photosynthetic organs to die completely They could redirect their energy into their roots and trunk, surviving harsh winters that would kill trees that tried to maintain their full biology year-round. They were teaching the world that sometimes the most beautiful death is the one that prepares for the most beautiful rebirth. Your ancestors learned from these seasonal masters that death could be not just individual or random, but cyclical and predictable, synchronized with the great rhythms that govern planetary life. They began developing internal biological calendars that could track not just daily rhythms, but annual ones. Genetic programs that could prepare for winter's approach months in advance by gradually shifting energy allocation and cellular priorities. It was like having internal weather forecasters that operated on geological timescales, predicting seasonal challenges and preparing biological responses accordingly. The estivation strategies that some of your ancestors developed in response to harsh summers represent the mirror image of hibernation, another form of seasonal near-death that demonstrates mortality's service to long-term survival. Desert animals learn to enter states of profound metabolic slowdown during the hottest, driest periods, essentially practicing death until the rains returned. They were becoming biological time travelers, using mortality as a tool for skipping over unsurvivable periods and awakening into more favorable conditions. Your modern sleep cycles still carry genetic echoes of these ancient seasonal mortality patterns. The daily death and resurrection you experience through sleep and waking reflects the same biological wisdom your ancestors developed for surviving seasonal cycles. Every night, your consciousness dies temporarily while your body conducts the maintenance and restoration activities that would be impossible during waking life. Your brain clears metabolic waste, consolidates memories, and repairs cellular damage through processes that are remarkably similar to the seasonal renewal your hibernating ancestors practiced. The seasonal affective patterns that many humans experience, the way your mood and energy naturally shift with changing day length and light quality, connect you directly to these ancient seasonal mortality cycles. Your ancestors developed genetic programs that could sense the approach of difficult seasons and begin preparing both physically and emotionally for periods of reduced activity and increased introspection. The winter melancholy that some people experience is actually an echo of ancient genetic wisdom, a biological signal that encourages rest, reflection, and energy conservation during nature's death season. Your reproductive cycles also reflect this seasonal mortality wisdom. Many mammals still time their reproduction to seasonal cycles, ensuring that offspring are born during optimal conditions, while adults are entering the seasonal death periods when they have the least energy available for child rearing. Your ancestors learned to coordinate individual mortality patterns with species survival needs, creating biological schedules where personal sacrifice supported collective continuity. The profound beauty of seasonal mortality lies in its demonstration that death and renewal can become partners in a dance that extends far beyond individual lifespans. Your ancestors were learning to participate in planetary rhythms, to synchronize their biological clocks with cosmic cycles, to make their individual mortality part of the larger seasonal mortality that governs all life on Earth. They were discovering that the most meaningful death is often the one that serves not just personal transcendence, but participation in the eternal cycles that sustain life itself. And here you are, still dancing to these ancient seasonal rhythms, still experiencing the subtle shifts in energy and mood that connect you to billions of years of cyclical mortality wisdom. Your body still knows how to prepare for winter, even in heated homes, still responds to changing light patterns, even under artificial illumination, still carries the genetic memory of ancestors who mastered the art of seasonal death and renewal. As we venture into one of evolution's most tender chapters, we arrive at a period roughly 200 million years ago, when your ancestors began developing perhaps the most profound response to mortality ever evolved, the capacity for grief. In the ancient world where death had become common, some lineages began experiencing something entirely new in cosmic history, emotional connections so deep that the death of one individual could create lasting psychological changes in others. It was evolution's first exploration of love as a biological force strong enough to transcend individual mortality. Picture your early mammalian ancestors as they first began forming pair bonds, family units, and social groups where individuals became emotionally invested in each other's survival. These weren't just strategic alliances for protection or reproduction, but genuine emotional attachments where the well-being of others became as important as one's own survival. Your ancestors were developing the biological capacity for empathy, for caring, for the kind of deep connection that would make another's death feel like a partial death of the self. The evolution of grief required your ancestors to develop new neural pathways, new brain structures capable of forming lasting emotional memories tied to specific individuals. Think of these early emotional bonding systems like biological photograph albums, where the brain could store not just images, but entire emotional landscapes associated with beloved companions. When those companions died, the emotional photographs remained, creating the first experiences of loss that were deeper than simple absence. The first taste of grief as love persisting beyond the physical presence of its object. Your mammalian ancestors were learning that mortality could create meaning as well as sadness, that the temporary nature of life could actually intensify the value of relationships rather than diminishing them. A mother caring for offspring she knew would someday die, a mate grieving the loss of a lifelong partner, a pack member mourning a fallen leader. These were the first biological philosophers, creatures who discovered that consciousness of mortality could deepen rather than weaken the bonds between living beings. The neurochemistry of grief that your ancestors developed reveals the profound biological wisdom hidden in emotional pain. The same chemical systems that create the joy of attachment, oxytocin and dopamine, also create the ache of loss when those attachments are severed by death. Your ancestors weren't developing separate systems for love and grief, but integrated emotional architectures where the capacity for deep connection necessarily included the capacity for deep loss. They were learning that you cannot have one without the other, that the price of love is always the possibility of grief. Your early primate ancestors took this emotional response to mortality even further, developing what we might call death consciousness, the ability to recognize and respond emotionally to death, even when it didn't directly affect their own family groups. They began showing curiosity about dead bodies, sometimes carrying dead infants for days, sometimes returning to visit the remains of deceased community members. They were becoming the first creatures capable of contemplating mortality as an abstract concept, rather than just experiencing it as an immediate emotional reality. The social functions of grief that your ancestors developed reveal how mortality became not just an individual experience, but a community-building force. Grief created the first biological rituals, behavioral patterns where surviving community members would gather around death, sharing the emotional burden of loss while reinforcing social bonds through mutual comfort. Your ancestors were discovering that shared grief could strengthen community connections, that mourning together could create forms of social solidarity that were impossible in species without emotional responses to mortality. Think about how grief began to function as a biological teaching system, where the emotional pain of loss motivated behavioral changes that improve survival outcomes. Animals that grieved the loss of community members were more likely to remember the circumstances that led to those deaths, more motivated to avoid similar risks, more attentive to signs of danger that might threaten remaining loved ones. Grief was becoming evolution's way of turning death into education, transforming loss into protective wisdom. Your ancestors also developed what we might call anticipatory grief, the ability to experience emotional distress when sensing that death might be approaching for loved ones. This emotional early warning system motivated increased caregiving, protective behavior, and resource sharing with vulnerable community members. It was like developing emotional radar that could detect mortality from a distance, triggering helping behaviors that might prevent loss before it occurred. The complex neurobiology of grief that you've inherited reveals how deeply these ancient, Emotional responses to mortality have been integrated into your basic brain architecture. The same neural pathways that process physical pain also process the pain of emotional loss, suggesting that your ancestors' brains learned to treat social death as a form of biological injury requiring attention and healing. When you experience grief, you're using neural machinery that was originally designed to help you respond to physical threats, now repurposed to help you navigate the emotional landscape of love and loss. Your capacity for memorial behavior, the human tendency to create monuments, tell stories about the deceased, and maintain connections with dead loved ones through ritual and memory, represents the ultimate flowering of your ancestors' grief evolution. You've developed the ability to use mortality as a catalyst for meaning-making, transforming death from pure loss into opportunities for celebrating life, preserving wisdom, and strengthening community bonds through shared remembrance. The comfort you find in cemetery visits, memorial services, and death anniversaries reflects ancient neural pathways that your ancestors developed for processing loss and maintaining social connections even across the boundary of death. These behaviors serve no obvious survival function, but they demonstrate how deeply your lineage has integrated emotional responses to mortality into the very foundation of social and psychological well-being. Perhaps most beautifully, your ancestors learned that grief could be a form of love that transcends mortality, a way of keeping emotional connections alive even after their physical foundation has ended. The dreams you have about deceased loved ones, the way their voices sometimes echo in your memory, the behavioral patterns you've inherited from them, all of these represent your ancestors' discovery that emotional bonds can survive individual death, creating forms of psychological continuity that complement the genetic continuity preserved through reproduction. And here you are, capable of loving so deeply that death becomes not just an ending, but a transformation of love's expression, able to grieve so profoundly that loss becomes a testimony to the value of what was shared. Your tears connect you directly to millions of years of mammalian evolution, to the first creatures who discovered that consciousness of mortality could deepen rather than diminish the capacity for emotional connection. That knowing death is inevitable could make life more precious rather than less meaningful. As we continue our gentle exploration through the vast library of evolutionary time, we encounter one of life's most beautiful realizations, that mortality could become the foundation for a form of inheritance, more sophisticated than anything the immortal world had ever imagined. Around 150 million years ago, your ancestors began developing what we might call cumulative mortality, the profound understanding that each generation's death could become the previous generation's gift to the future, a biological legacy system where dying became a form of giving. Picture your early mammalian ancestors as they first learned to practice what biologists call parental investment, the deliberate sacrifice of personal resources and even lifespan to improve their offspring's chances of survival and success. Unlike the simple cell division of immortal bacteria, where parent cells merely copied themselves, these new forms of reproduction required parents to literally give pieces of their own life force to create not just new individuals, but better individuals, improved versions that carried forward their parents' wisdom while transcending their limitations. Think of this process like an ancient library where each generation of librarians would spend their entire careers not just maintaining the collection, but carefully curating it, adding new valuable texts while removing outdated ones, organizing information more effectively, and developing better cataloging systems. When each generation of librarians died, they would pass on not just the books they had inherited, but a more valuable, more organized, more useful collection than they had received. Your ancestors were becoming biological librarians of genetic wisdom, using their mortality to continuously improve the hereditary collection. The development of complex parental care represents evolution's first systematic exploration of how individual death could serve genetic immortality. Your mammalian ancestors learned to program their own aging to synchronize with their offspring's development, often literally wearing themselves out through the intensive work of raising young, but ensuring that their genetic legacy would be carried forward by individuals better equipped for survival than they had been themselves. They were discovering that the most meaningful mortality is often the one that enables others to live more successfully. Consider the profound biological mathematics of this inheritance system. Each generation of your ancestors had to calculate how much of their own life force they could safely invest in their offspring without dying before those offspring could become independent. They developed genetic programs that could balance current survival needs with future reproductive success, creating lifespan strategies that maximize the total amount of life they could generate rather than just the length of their individual existence. Your mammalian ancestors also began developing sophisticated learning systems that allowed them to acquire wisdom during their lifetimes and pass at least some of that wisdom to their offspring through behavioral teaching. Unlike genetic inheritance, which was automatic, this cultural inheritance required parents to survive long enough to educate their young, but not so long that they would compete with their offspring for resources. They were learning to use their mortality as a teaching schedule, dying at precisely the moment when their wisdom had been successfully transferred to the next generation. The evolution of menopause in some mammalian lineages represents perhaps the most sophisticated example of mortality as inheritance strategy. Females of certain species learned to stop reproducing while still living for many years, redirecting their energy from creating new offspring to helping existing offspring raise their own young. They were discovering that sometimes the best genetic strategy involved practicing reproductive death while maintaining biological life, using their remaining years to amplify their genetic legacy through grandchildren rather than additional children. The epigenetic inheritance systems that your ancestors developed during this period represent perhaps evolution's most elegant solution to the question of how mortality could enable the accumulation of wisdom across generations. Through chemical modifications to their DNA that could be passed to offspring, your ancestors learned to inherit not just genetic information, but environmental knowledge, behavioral adaptations, and even stress responses that had been learned rather than evolved. They were discovering that death could preserve not just what they were born with, but what they had learned during their lifetimes. Think of epigenetic inheritance like a biological annotation system, where each generation could add margin notes to the genetic text they inherited, providing context and guidance that would help their offspring navigate similar challenges more successfully. When your ancestors experienced famine, trauma, or environmental stress, they could chemically mark their DNA with information that would help their offspring's bodies prepare for similar challenges. Their mortality became a mechanism for concentrating lifetime learning into genetic wisdom that could benefit future generations. Your ancestors were also developing increasingly sophisticated ways to die that would maximize their genetic legacy. The timing of parental death began to evolve in coordination with offspring development, creating species-specific patterns where parents would naturally reach the end of their programmed lifespans, just as their offspring reached independence. It was like biological choreography, where individual mortality was timed to serve genetic continuity, where personal endings were scheduled to enable collective beginnings. The development of extended family structures among your ancestors represents another beautiful application of mortality as inheritance strategy. Grandparents, aunts, uncles, and older siblings learned to contribute to child rearing even when they were no longer reproducing themselves, using their remaining lifespan to amplify the genetic success of related individuals. They were discovering that genetic inheritance could be a community project, where the mortality of multiple individuals could be coordinated to maximize the survival and success of shared genetic lineages. Your human capacity for teaching and learning represents the ultimate flowering of mortality as inheritance mechanism. Unlike any other species, you can inherit not just genetic information and simple behavioral patterns, but complex knowledge, skills, cultural practices, technological innovations, and abstract ideas. Your mortality creates the generational turnover that prevents human culture from becoming frozen in outdated ideas. while ensuring that valuable wisdom is carefully preserved and passed forward through education, storytelling, and cultural transmission. The way you prepare for your own death through wills, life insurance, recorded messages, and other legacy planning reflects this ancient wisdom about mortality as gift-giving. You instinctively understand that your death can be an opportunity to give rather than just to lose, to contribute rather than just to end, to create inheritance that will benefit others long after your individual existence has concluded. You are practicing the same mortality wisdom your ancestors developed millions of years ago, using your finite lifespan as an opportunity to maximize your positive impact on future generations. The profound truth that emerges from contemplating mortality as inheritance is that your death, far from being a failure or tragedy, is actually your final contribution to the ongoing project of life itself. Every choice you make about how to live and how to prepare for dying becomes part of the legacy you leave, part of the genetic and cultural inheritance that will shape the future. Your ancestors discovered that the most meaningful mortality is the one that serves not just personal completion, but the continuation and improvement of the larger story of which you are a chapter. And here you are, the living beneficiary of millions of generations of ancestors who used their mortality as a gift-giving opportunity, who chose to die in ways that would maximize your chances of not just surviving, but thriving. Every advantage you possess, every capability you inherit, every opportunity you have to contribute positively to the world, all of these are the accumulated gifts of ancestors, understood that meaningful death is always death in service of meaningful life. As we drift deeper into the recent chapters of evolutionary time, we encounter one of mortality's most powerful innovations, the way limited lifespans began creating biological urgency that transformed not just individual behavior, but the entire pace and direction of evolutionary change. Around 100 million years ago, your ancestors discovered that knowing death was inevitable could become a catalyst for living more intensely, more purposefully, more creatively than immortal beings ever could. Picture your ancestors as they first began developing what we might call mortality awareness, the biological capacity to sense their own aging and respond to it by intensifying their life activities. Unlike immortal organisms that could approach every activity with infinite patience, mortal organisms had to develop time management skills, prioritization strategies, and efficiency improvements that would allow them to accomplish their biological goals within the constraints of finite lifespans. They were becoming the universe's first experts in productive urgency, creatures who could use the pressure of limited time to enhance rather than diminish their life achievements. Think of this period like the development of biological project management, where organisms learn to organize their activities around deadlines imposed by their own programmed mortality. Young animals had to learn survival skills quickly enough to become independent before their parents died. Adults had to reproduce successfully before their fertility declined. Aging individuals had to pass on their accumulated wisdom before their memory systems began to fail. Your ancestors were developing life strategies based on the profound recognition that time was their most precious and limited resource. The seasonal breeding patterns that many of your ancestors developed demonstrate how mortality awareness could create beneficial constraints that actually increased reproductive success. Instead of trying to reproduce continuously like immortal bacteria, mortal animals learned to concentrate their reproductive efforts during optimal seasons, using the rest of their limited lifespans to gather resources, develop skills, and prepare for brief but intensive periods of genetic contribution. They were discovering that intermittent reproduction could be more successful than constant reproduction when individual lifespans were finite. Your ancestors were also learning that limited time could enhance rather than diminish the quality of experiences. A sunset is beautiful partly because it ends. A flower is precious partly because it blooms briefly. A life is meaningful partly because it concludes. Your mortal ancestors began developing neural systems that could appreciate the transient nature of experiences, finding beauty and meaning in temporal limitations that immortal beings might never understand. They were becoming the first creatures capable of nostalgia, of bittersweet appreciation for moments that were beautiful, partly because they couldn't last forever. The migration timing that many of your ancestors perfected illustrates how mortality awareness could improve decision-making across vast scales of time and space. Birds that migrated too early might face harsh weather, but those that migrated too late might miss optimal breeding conditions. With limited lifespans providing only a few opportunities to make these crucial timing decisions, your ancestors developed exquisitely sensitive biological calendars that could read subtle environmental cues and time major life transitions with remarkable precision. They were learning that mortality could be a teacher of timing, that limited opportunities could create wisdom about when to act and when to wait. The learning acceleration that mortality created in your ancestors reveals how limited time could actually expand rather than constrain cognitive capabilities. Animals with finite lifespans had to develop rapid learning systems, efficient memory formation, and quick decision-making processes that would allow them to acquire essential skills within the time constraints of their biological schedules. They were becoming biological students, attending intensive courses where graduation was mandatory and the final exam was survival itself. Your ancestors developed what we might call mortality motivation, biological drive systems that could use awareness of finite time to intensify focus, dedication, and effort. The urgency created by limited lifespans motivated innovations in efficiency, creativity, and problem-solving that would have been unnecessary in an immortal world. They were discovering that constraints could be liberating, that limitations could spark creativity, that the pressure of finite time could compress lifetimes of achievement into remarkably brief periods. The mate selection strategies that your ancestors refined during this period show how mortality awareness could improve reproductive decision-making. With limited time for reproduction and limited opportunities to choose mates, your ancestors developed increasingly sophisticated systems for evaluating potential partners, selecting not just for immediate survival traits, but for genetic combinations that would produce the most successful offspring. They were learning to use their mortality as motivation for genetic optimization, ensuring that their brief lifespans would contribute maximally to the ongoing evolutionary project. Your human creativity represents perhaps the ultimate expression of mortality as motivational catalyst. The awareness that your time is limited, that your opportunities to create and contribute are finite, motivates artistic, intellectual, and social innovations that might never emerge in immortal beings who could always postpone creative work for some indefinite future moment. Your mortality creates the beautiful pressure that transforms potential into achievement, dreams into reality, inspiration into legacy. The career patterns that humans develop, the way you naturally intensify your productive efforts during your prime adult years, while knowing that your peak performance period is limited, reflects this ancient wisdom about mortality as motivational force. You instinctively understand that your professional capabilities will peak and then decline, and this understanding motivates you to accomplish as much as possible during your biological prime while preparing for the different contributions you might make during your later years. Your bucket lists, life goals, and long-term planning reflect the same mortality-driven prioritization systems your ancestors developed millions of years ago. The knowledge that you cannot do everything motivates you to choose carefully, to focus on what matters most, to make decisions based on what will create the most meaning and satisfaction within the time you have available. Your mortality is not a limitation on your dreams, but a focusing lens that helps you distinguish between what you want to do and what you really need to do. The urgency that you sometimes feel about making your life meaningful, about leaving a positive legacy, about contributing something valuable to the world, connects you directly to this ancient evolutionary wisdom about mortality as catalyst. Your ancestors learned that limited time could motivate unlimited creativity, that finite lifespans could generate infinite innovations. That individual mortality could serve collective immortality by ensuring that each generation builds upon, rather than merely repeats the achievements of previous generations. And here you are, using the precious pressure of your own mortality to motivate choices, inspire creativity, deepen relationships, and create meaning that will persist beyond your individual existence. Your finite time is not a cosmic punishment, but an evolutionary gift, a sophisticated motivational system that your ancestors refined over millions of years to help you live not just longer, but better, not just successfully, but meaningfully. The urgency you feel is not anxiety about death, but excitement about life. The biological enthusiasm that emerges when consciousness meets mortality and transforms limitation into liberation. As we continue our contemplative journey through the vast expanse of evolutionary innovation, we arrive at one of mortality's most profound and beautiful applications, the development of death as a memory preservation system. Roughly 50 million years ago, your ancestors began discovering that individual mortality could serve not just genetic continuity, but information continuity, creating biological libraries where the death of individuals could actually strengthen and preserve collective knowledge across vast spans of time. Picture your early primate ancestors as they first began developing what we might call transgenerational learning, the ability to accumulate knowledge that could survive individual death and be passed to future generations through teaching, imitation, and cultural transmission. Unlike the purely genetic inheritance that had dominated earlier evolutionary periods, these new forms of information preservation required individuals to die at precisely the right time to maximize knowledge transfer, creating biological universities where mortality became the graduation ceremony that marked the successful completion of wisdom transmission. Think of this innovation like the development of biological publishing systems, where each individual's lifetime became an opportunity to author new chapters in the ongoing encyclopedia of species knowledge. Your ancestors learned to use their mortality not just to make room for new genetic combinations, but to create opportunities for new behavioral innovations, new problem-solving strategies, new environmental adaptations that could be learned once and then taught to countless future generations. The grandmother hypothesis that explains human female longevity demonstrates how your more recent ancestors optimized mortality timing to maximize information preservation. Post-reproductive human females live for decades beyond their reproductive years, using their extended lifespans to accumulate and transfer knowledge, skills, and cultural wisdom to their descendants. They are practicing mortality as a form of teaching career, where individual death is delayed just long enough to ensure that lifetime learning can be successfully transmitted to multiple generations of offspring. Your ancestors developed increasingly sophisticated systems for encoding different types of information in ways that could survive individual mortality. Genetic information was preserved through DNA replication. Behavioral information was preserved through demonstration and imitation. Environmental information was preserved through territorial marking and habitat modification. Social information was preserved through communication systems that could carry knowledge about relationships, hierarchies, and group dynamics across generational boundaries. Consider the profound biological wisdom required to create these transgenerational memory systems. Your ancestors had to develop neural architectures that could distinguish between information worth preserving beyond individual death and information that could safely die with each individual. They were becoming biological editors, curating the accumulated knowledge of their lifetimes and selecting the most valuable pieces for transmission to future generations. The death of individuals became an opportunity for species-level quality control of inherited information. The oral tradition systems that your more recent human ancestors developed represent perhaps the most sophisticated evolution of mortality as memory preservation. Through storytelling, songs, rituals, and other cultural practices, humans learn to encode complex information in memorable forms that could survive individual death and be transmitted across generations with remarkable fidelity. Your ancestors were transforming their finite lifespans into chapters in an immortal cultural story, using their mortality to contribute to a collective memory system that could accumulate wisdom indefinitely. The written language systems that humans eventually developed represent the ultimate expression of mortality as memory preservation technology. By learning to encode information in external symbols that could persist long after their creators died, your ancestors transcended the biological limitations of memory storage within individual brains. They were creating the first truly immortal information systems, where individual mortality could contribute to collective knowledge that could theoretically persist forever. Your modern internet and digital storage systems represent the latest evolution of this ancient principle, mortality-driven information preservation. The knowledge you access online exists partly because countless individuals throughout history chose to record their discoveries, insights, and innovations before dying, contributing their finite lifespans to an ever-growing repository of human wisdom. Every time you learn something from a book, video, or website created by someone who is no longer alive, you're participating in the same transgenerational knowledge transfer system your ancestors began developing millions of years ago. The scientific method itself reflects this mortality-driven approach to knowledge preservation and improvement. Scientists use their limited lifespans to conduct experiments, make discoveries, and document their findings in ways that can be verified and built upon by future generations. The death of individual scientists doesn't end scientific progress, but actually accelerates it, as each generation can build upon the documented discoveries of previous generations while questioning assumptions and exploring new frontiers that previous generations couldn't investigate within their own finite lifespans. Your educational systems demonstrate how modern humans have refined mortality as a teaching catalyst. The knowledge you acquired in school exists partly because teachers throughout history used their limited lifespans to master specific subjects and develop effective methods for transmitting that knowledge to students. The death of great teachers doesn't end their educational impact, but actually amplifies it, as their methods and insights continue to influence students who become teachers themselves, creating cascading chains of knowledge transmission that can persist for centuries. The way you form and maintain memories throughout your own lifetime reflects these ancient systems for using mortality to enhance rather than diminish information preservation. Your brain continuously selects which experiences to encode in long-term memory and which to allow to fade away, essentially practicing a form of selective forgetting that parallels the selective preservation your ancestors developed for transgenerational knowledge transfer. Your personal mortality motivates you to pay attention to what matters most, to remember what will serve you best, to let go of information that no longer supports your well-being or growth. Your capacity for nostalgia, for treasuring memories of deceased loved ones, for preserving family histories and cultural traditions, represents the emotional dimension of mortality-driven memory preservation. You instinctively understand that death makes memories more precious rather than less valuable, that the finite nature of relationships motivates you to pay attention more carefully, to record experiences more thoughtfully, to appreciate moments more deeply, because you know they cannot last forever. The digital legacy planning that many modern humans engage in, creating archives of photos, videos, and written communications that will survive their death, represents the latest chapter in this ancient story of mortality as memory preservation. You are using modern technology to practice the same wisdom your ancestors developed millions of years ago, using awareness of your finite lifespan to create information preservation systems that can contribute to collective human knowledge and culture long after your individual consciousness has ended. And here you are, participating in the grandest memory preservation project in cosmic history, using your limited time to learn from those who died before you while creating knowledge and experiences that will inform and inspire those who will live after you. Your mortality is not an obstacle to meaning, but the very foundation of meaning, the biological constraint that motivates you to transform your finite existence into infinite contribution, your temporary presence into permanent legacy. As we venture into one of evolution's most elegant discoveries, we encounter the period roughly 30 million years ago, when your ancestors began perfecting perhaps the most beautiful application of mortality as a creative force, the development of complex ecological networks where death became the foundation for life's abundance rather than its limitation. In the ancient forests and grasslands, life learned to create communities where the death of some members could nourish and sustain countless others, transforming individual endings into collective beginnings on a scale that would reshape entire landscapes. Picture your ancestors as they first learned to participate in what we might call the Great Cosmic Recycling Program, ecological webs where every death became a gift to the living, where every ending enabled multiple new beginnings. Unlike the simple bacterial mats of early evolution, where death was merely absence, these complex ecosystems transformed death into presence, into the fundamental currency that powered the circulation of energy and nutrients through increasingly intricate biological communities. Think of these early ecological networks like vast natural economies where death served as the primary form of currency exchange. When a tree died and fell in the ancient forests, it didn't simply disappear, but became a biological bank account that could support decades of other life forms. Fungi would consume its cellulose, insects would nest in its bark, small mammals would shelter in its hollows, and countless microorganisms would slowly transform its complex molecules into simple nutrients that new trees could absorb and use for growth. Death had become evolution's most effective wealth redistribution system. Your vertebrate ancestors learned to participate in these death-powered ecosystems as both contributors and beneficiaries, developing feeding strategies that depended on the mortality of other organisms, while preparing their own eventual death to serve the community that had sustained them. Predators learned to hunt not with wasteful excess, but with ecological wisdom, taking only what they needed while ensuring that prey populations remained healthy enough to continue providing for future generations. They were becoming biological philosophers of sustainable mortality, creatures who understood that individual death could serve collective life when approached with the right balance of restraint and gratitude. The decomposer organisms that your ancestors evolved alongside represent perhaps the most dedicated practitioners of death as transformation service. Bacteria, fungi, and other decomposers learned to specialize in the alchemy of converting complex dead organic matter into simple nutrients that could be absorbed by living plants. They were becoming biological resurrection specialists, creatures whose entire existence was devoted to ensuring that death never became waste, but always became opportunity for new life. Consider the mathematical beauty of these ecological death cycles. In healthy ecosystems, the rate of death and decomposition perfectly balances the rate of growth and reproduction, creating stable systems where energy and nutrients circulate continuously without ever being depleted. Your ancestors were learning to participate in biological economies where death was neither loss nor gain, but transformation, where the total amount of life remained constant even as individual organisms came and went, where mortality served as the circulation system that kept the entire community healthy and sustainable. The keystone species roles that some of your ancestors developed demonstrate how individual mortality could be leveraged to support entire ecosystem health. Wolves, for example, learned to practice mortality management on ecosystem scales, their hunting patterns creating death that prevented prey overpopulation, while their own eventual deaths returned nutrients to soil systems that supported plant communities that fed herbivores that fed carnivores in endless beneficial cycles. They were becoming biological conductors, orchestrating ecosystem symphonies where death and life played complementary melodies that enhanced rather than competed with each other. Your ancestors also developed seasonal death strategies that could power entire ecosystem renewal cycles. The autumn leaf fall that you witness each year represents a massive coordinated death event where trees sacrifice their photosynthetic organs to create a nutrient blanket that will feed soil organisms through winter and support explosive spring growth. The salmon runs that still occur today demonstrate another form of coordinated mortality, where adult fish die in mass after reproducing, providing crucial nutrients to forest ecosystems hundreds of miles from the ocean, while ensuring that their offspring have optimal conditions for development. The predator-prey cycles that your ancestors refined show how mortality could be used to create sustainable abundance rather than scarcity. Population booms in prey species would trigger increased predation, reducing prey numbers through increased death rates, while providing abundant food that would support predator reproduction. As prey populations declined, predator populations would also decline through reduced reproduction and increased mortality, allowing prey populations to recover and begin the cycle again. Your ancestors were learning that ecological death could be rhythmic rather than random, cyclical rather than chaotic, ultimately serving life's abundance rather than threatening it. Your human agricultural systems represent a conscious application of these ancient ecological death principles. When you compost organic waste, you're practicing the same death-to-life transformation that your ancestors learned from forest ecosystems. When you rotate crops to prevent soil depletion, you're applying ecological wisdom about how temporary death of certain plant communities can serve long-term soil health. When you manage livestock populations, you're using controlled mortality to maintain sustainable population levels while providing nutrition for human communities. The carbon cycle that sustains all life on Earth represents perhaps the ultimate expression of death as ecological service system. Every time you exhale, you're participating in a planetary circulation system where the death of organic molecules in your cells creates carbon dioxide that plants can absorb and transform into new organic molecules through photosynthesis. When you die, your body will return its accumulated carbon to this global cycle, contributing to the atmospheric resources that will support plant growth for millions of years. You are not just mortal, but cyclically immortal, participating in planetary scale systems where individual death serves cosmic life. The extinction events that periodically reshaped life on Earth taught your ancestors perhaps the most profound lesson about ecological mortality, that even the death of entire species could serve the long-term health of the biosphere by making room for new, adaptive innovations. The dinosaur extinction that ended the Mesozoic era was a planetary tragedy, but it was also the event that made mammalian diversification possible, clearing ecological niches that your mammalian ancestors could colonize and eventually leading to the evolution of primates, humans, and your own existence. Your environmental awareness, your instinctive understanding that human activity can affect entire ecosystems, reflects this ancient wisdom about mortality as ecological responsibility. You intuitively recognize that your species' impact on other species' mortality rates affects the health of the planetary systems that sustain all life, including your own. Your consciousness of environmental issues represents the flowering of millions of years of evolution that taught your ancestors to consider their mortality, not just as individual destiny, but as ecological participation. And here you are, breathing oxygen produced by plants that grew from soil enriched by the decomposed remains of countless generations of organisms, eating food that emerged from agricultural systems powered by ecological death and renewal cycles, living in a biosphere that has been shaped by millions of years of mortality, serving as the foundation for life's abundance rather than its limitation. You are not separate from these ecological death cycles, but intimately connected to them, participating in planetary systems where your eventual mortality will serve the same life-supporting functions that have sustained the Earth's biological communities for hundreds of millions of years. As we approach the present moment in our vast journey through evolutionary time, let us quietly contemplate the extraordinary inheritance that flows through your mortal body, the accumulated wisdom of 3.5 billion years of experimentation with death as life's greatest collaborator. Every cell in your body carries genetic programs that represent evolution's masterpiece in mortality engineering. Sophisticated biological systems that coordinate your aging, your healing, your daily rhythms, and your eventual death with an elegance that took eons to perfect. Picture yourself as a living museum of mortality innovations, where each system in your body demonstrates a different evolutionary solution to the challenge of using death creatively. Your telomeres, the protective caps on your chromosomes, function like cellular calendars that shorten with each cell division, providing each cell with its own aging clock that was first developed by your earliest eukaryotic ancestors billions of years ago. They are like tiny genetic hourglasses, measuring out the lifespan of individual cells while coordinating their death with the needs of your larger biological community. Think about the remarkable sophistication of your hormonal aging systems, chemical messenger networks that can coordinate the aging of different organ systems, according to different schedules optimized over millions of years of mammalian evolution. Your reproductive hormones decline on a schedule that reflects ancient wisdom about when fertility should end to maximize the survival of existing offspring. Your growth hormone production slows according to genetic programs that balance continued maintenance with the energy needs of other biological priorities. Your stress hormone systems change with age in ways that help you shift from the high energy demands of youth to the different but equally important contributions of maturity and later life. Your brain's aging patterns demonstrate perhaps the most beautiful example of programmed mortality serving cognitive optimization. While some neural functions decline with age, others actually improve, reflecting genetic programs that can distinguish between biological processes that should be maintained indefinitely and those that should change to serve different life phases. Your older brain becomes better at synthesis, wisdom, and pattern recognition, while becoming less focused on rapid information processing and new memory formation. Your ancestors were learning that different types of intelligence could be optimized for different phases of the aging process. The immune system changes that accompany your aging reflect ancient genetic programs that balance individual longevity with species survival. Your immune function gradually declines with age, partly because evolution optimized your immune investment for your reproductive years, when your survival was most crucial for genetic continuity. The immunosenescence you'll experience is not a design flaw, but a conscious biological trade-off, redirecting energy from immune maintenance to other biological priorities that serve different functions during later life phases. Your sleep pattern changes throughout your lifespan demonstrate how your ancestors learned to coordinate mortality awareness with daily renewal cycles. The sleep needs of childhood support the intensive growth and learning required for development. The sleep patterns of adulthood balance restoration with productivity demands. The changing sleep architecture of aging reflects genetic programs that shift priorities from growth and learning to maintenance and wisdom consolidation. Your ancestors were learning to use mortality awareness to optimize different types of rest for different life phases. Consider how your emotional relationship with your own aging reflects millions of years of evolutionary psychology devoted to helping organisms navigate their programmed mortality with grace and purpose. The midlife evaluations that many humans experience, the increasing focus on meaning and legacy that often accompanies aging, the growing appreciation for relationships and experiences over material accumulation, all of these represent genetic wisdom about how to use mortality awareness to enhance rather than diminish life satisfaction. Your human lifespan of roughly 70 to 80 years represents perhaps evolution's most carefully optimized mortality program, a biological schedule that balances individual achievement with species adaptation, personal meaning with genetic continuity, individual learning with cultural transmission. Your ancestors spent millions of years fine-tuning this lifespan length, extending it just long enough to allow for wisdom accumulation and grandparent investment while keeping it short, enough to enable generational turnover and continued evolutionary flexibility. The way your body manages cellular replacement throughout your lifetime demonstrates the extraordinary sophistication of your inherited mortality programs. Your heart muscle cells are programmed to last your entire lifespan, reflecting the critical importance of cardiac function for survival. Your skin cells replace themselves every few weeks, balancing protection needs with renewal efficiency. Your brain cells follow complex replacement schedules, with some neurons lasting your entire lifetime, while others turn over regularly to maintain cognitive flexibility. You are a carefully orchestrated symphony of different mortality timelines, each optimized for its specific biological function. Your reproductive aging patterns reveal ancient genetic wisdom about how individual mortality should be coordinated with species continuity. The fertility changes you experience throughout your lifespan reflect millions of years of optimization for producing offspring. When you have the most energy and resources available for parenting, while ensuring that you live long enough beyond your reproductive years to contribute to your offspring's success through teaching, protection, and resource sharing. Your ancestors learned that the most effective genetic strategy involved practicing reproductive mortality long before biological mortality. The wisdom changes that accompany human aging demonstrate how your mortality programs actually enhance certain cognitive capabilities, even as they diminish others. The crystallized intelligence that increases throughout your lifespan, your improving ability to see patterns, make connections, and understand complex relationships, reflects genetic programs that use mortality awareness to motivate the consolidation and integration of lifetime learning. Your ancestors were learning that aging could be a form of mental maturation rather than just mental decline. Your instinctive awareness of your own mortality, the way you naturally begin thinking about legacy and meaning as you age, represents perhaps the most sophisticated mortality consciousness ever evolved. You are the first species in Earth's history capable of understanding your own death, not just as an inevitable future event, but as a meaningful part of your current existence, a biological fact that can inform your daily choices and long-term planning. Your ancestors gave you the remarkable gift of being able to live your life in conscious dialogue with your own mortality. The healthcare decisions you make throughout your lifetime reflect your participation in evolutionary strategies for optimizing your inherited mortality programs. When you exercise, eat well, manage stress, and maintain social connections, you're using modern knowledge to support the ancient genetic programs that coordinate your aging. When you seek medical treatment for age-related conditions, you're accessing technologies that can help your body's mortality programs function as they were designed to, aging gracefully rather than suffering unnecessarily. Your end-of-life planning activities, your advance directives, your decisions about how you want to die represent the ultimate expression of human participation in programmed mortality. You are the first species capable of consciously collaborating with your own death programs, making informed decisions about how your mortality should serve not just your individual completion, but your contribution to the ongoing communities that will survive your death. The profound truth that emerges from contemplating your programmed mortality is that every aspect of your aging represents genetic wisdom, accumulated over billions of years of evolutionary experimentation with death as a creative force. Your mortality is not a random accident or a cosmic punishment, but a carefully designed biological program that coordinates your individual death with the health continuity of the larger living systems of which you are a part. And here you are, the conscious inheritor of humanity's optimized mortality program, living a lifespan that has been evolutionarily calibrated to enable your maximum contribution to genetic continuity, cultural evolution, and personal meaning. Your aging is not evidence of biological failure, but proof of biological success, demonstration that your ancestors successfully solved the great challenge of using individual mortality to serve collective immortality while enabling the kind of complex consciousness that can understand and appreciate the very mortality that makes it possible. As our gentle journey through the vast epochs of evolutionary time draws toward its natural conclusion, let us rest for a moment in quiet contemplation of the extraordinary story we have shared together. We have traveled through 3.5 billion years of cosmic innovation, witnessing how life transformed death from random accident into purposeful gift, from biological limitation into creative liberation, from individual ending into collective beginning. We have seen how your mortality is not life's failure, but its greatest success, not a problem to be solved, but a solution to the deepest challenges of existence itself. Think about the profound journey we have taken together, from those first immortal bacterial cells dividing endlessly in ancient seas to your own complex consciousness contemplating its finite nature under starlight that has traveled billions of years to reach your eyes. Every chapter of this story has revealed another dimension of mortality's service to life, another way that death has enabled rather than prevented the flowering of complexity, beauty, and meaning that you represent in this moment. Your ancestors spent billions of years learning that the most beautiful forms of life are those that embrace their own endings, that the most meaningful existence is often the most temporary one, that the most profound creativity emerges when consciousness recognizes its own finite nature and chooses to use that limitation as inspiration rather than despair. They were teaching the universe that immortality without growth is stagnation, that permanence without change is imprisonment, that existence without ending is a story that can never find its meaning. Consider the extraordinary gift that your mortality represents, not just for you personally, but for the ongoing project of life itself. Your finite lifespan motivates you to love more deeply, learn more intensively, create more boldly, and contribute more meaningfully than any immortal being possibly could. Your awareness of death enhances every experience with preciousness, transforms every relationship with urgency, infuses every moment with the possibility of significance that only temporary existence can provide. The tears you shed when contemplating your own mortality or the death of loved ones connect you directly to this ancient story, to the first creatures who developed emotional responses to death and discovered that grief could be a form of love, that loss could be a teacher of value, that endings could be celebrations of what was shared rather than just mourning for what was lost. Your capacity for both sadness and joy in the face of mortality represents the culmination of billions of years of emotional evolution devoted to helping conscious beings navigate the beauty and challenge of finite existence. Your daily participation in the cycles of cellular death and renewal, your nightly journey through sleep's temporary mortality, your seasonal shifts in mood and energy, your life phase transitions from childhood through adulthood to elderhood, all of these demonstrate how completely your existence is integrated with the mortality wisdom your ancestors developed. You are not fighting against death, but dancing with it, not resisting mortality, but collaborating with it in the same creative partnership that has powered evolution for eons. The legacy planning that humans naturally engage in, your instinctive desire to leave something meaningful behind when you die, represents the latest chapter in this ancient story of mortality as gift-giving. Whether through children, creative works, professional achievements, volunteer service, or simply the positive impact you have on others' lives, you are practicing the same wisdom your ancestors learned billions of years ago, using your finite existence to contribute to ongoing projects that will persist beyond your individual participation. Your capacity for finding meaning in mortality, for seeing your limited time as an opportunity rather than just a constraint, represents perhaps evolution's greatest achievement in consciousness development. You are the first species capable of consciously appreciating your own mortality, of understanding death not as life's enemy, but as its closest collaborator, of recognizing that your finite existence is what makes infinite meaning possible. You can contemplate the very mortality that enables your contemplation, creating recursive loops of consciousness that would be impossible without the temporal boundaries that define individual existence. The gratitude you feel when you truly understand this story, when you recognize your mortality as the culmination of billions of years of evolutionary gift-giving, connects you to the deepest wisdom life has ever discovered. Your ancestors learned that the most profound form of biological success involves not just surviving, but enabling others to thrive. Not just persisting, but participating in ongoing creativity. Not just existing, but contributing to existence itself. Your bedtime contemplation of mortality. The way thinking about death can sometimes be oddly comforting rather than frightening, reflects your genetic inheritance of this ancient wisdom. You instinctively understand that your mortality connects you to every organism that has ever lived, that your death will reunite you with the cosmic processes that gave birth to your consciousness, that your finite existence is your ticket to participation in the infinite creativity of the universe itself. The peace that can come from accepting your mortality represents the emotional culmination of billions of years of evolution, learning to embrace endings as beginnings, death as transformation, individual limitation as cosmic contribution. When you feel genuine acceptance of your own eventual death, you are experiencing the same biological wisdom that your ancestors used to transform random mortality into purposeful mortality, accidental death into conscious collaboration with the forces that shape life's ongoing evolution. Your children, students, friends, and anyone whose life you touch positively will carry forward not just your genetic legacy, but your conscious contributions to the human cultural project that builds upon biological evolution. Through them, aspects of your consciousness, your wisdom, your love, and your creativity will persist and continue influencing the world long after your individual mortality has been completed. You are practicing the same mortality wisdom your ancestors developed, using death as a mechanism for transcendence rather than termination. The story we have shared tonight reveals that your mortality is not something that happens to you, but something you actively participate in. Not a biological accident, but a biological masterpiece. Not life's limitation, but life's greatest innovation. You are the conscious flowering of 3.5 billion years of evolution, learning to use death as the foundation for increasingly complex and beautiful forms of existence. And here you are in this moment, breathing quietly in the gentle darkness, your finite consciousness contemplating the infinite story of which it is a precious part, your temporary existence connected to eternal processes that transform individual endings into collective beginnings, your personal mortality serving as both the conclusion of your individual story and your contribution to the ongoing story of life itself, which has no ending because it has learned to use endings as its most powerful tool for continued creativity, continued evolution, continued discovery of what it means to exist consciously in a universe where death and life have become partners in the endless dance of cosmic becoming. And so, dear fellow traveler through the vast corridors of time, we arrive at the gentle end of our contemplative journey through 3.5 billion years of evolution's most profound innovation. We've drifted together through the ages and discovered that death is not life's accident, but its greatest achievement. Not biological failure, but biological wisdom. Not the end of the story, but the very mechanism that allows the story to continue growing more beautiful with each passing eon. Along the way, we've seen that mortality is not just inevitable change, but purposeful transformation, the cosmic force that enabled your immortal bacterial ancestors to become your magnificently complex self. From those first random cellular deaths in ancient seas to your own sophisticated aging programs, we've witnessed how life learned to use endings as beginnings, limitations as liberations, individual sacrifice as collective advancement. We've discovered that your finite existence is not life's compromise with cosmic limitation, but life's ultimate collaboration with cosmic creativity. So let me ask you once more, gently as I did at the start of our temporal journey, where are you listening from tonight? And as you consider that question, remember that wherever you are participating in the same planetary cycles of death and renewal that your ancestors helped to create. Breathing oxygen produced by photosynthesis powered by seasonal leaf death, nourished by food grown in soil, enriched by countless generations of decomposed organisms, warmed by the light of a star that dies a little each day to sustain life throughout the solar system. If you found any comfort, wisdom, or gentle fascination in this quiet expedition through the evolution of mortality? I'd be ever so grateful if you'd like the video, maybe subscribe, and share this contemplative journey with someone else who might find peace in understanding the profound gift of finite existence. This corner of the internet exists to help curious minds find rest in the beautiful truths that science reveals about our place in the cosmic story. The vast sweep of evolutionary time has taught us that your mortality is not a limitation imposed upon consciousness, but consciousness's greatest tool for participating meaningfully in the ongoing creativity of existence itself. You are not just mortal, but consciously mortal, able to understand and appreciate the very biological programs that coordinate your aging, your healing, your daily renewal, and your eventual transformation back into the cosmic processes from which you emerged. Your death, when it comes, will not be life's failure, but life's graduation ceremony. The moment when your individual contribution to the ongoing project of conscious existence will be lovingly integrated into the eternal story that has no ending, because it has learned to use endings as its most powerful tool for continued growth. Sleep well, fellow traveler through time, wherever and whenever you are, knowing that your finite existence is infinite gift. Your temporary presence is eternal contribution. Your mortal consciousness is immortal participation in the universe, coming to know itself through countless individual perspectives that bloom and fade, like flowers in an endless cosmic garden where every ending enables new beginnings.